concept should also be clear. Concept.
Yeah, concepts have to be clear. Again, an important point. So, okay, so we'll start. So, welcome everybody to this series of lectures. So, my name is Prashant, and I will be conducting the physics-related discussion for this. And in the subsequent days, we will also have chemistry and mathematics by other teachers. So, let me just share my screen. Okay, can you see my screen? Please confirm.
Yes.
Okay, good. Okay, so just to give some introduction about what I plan to do today, and in the so today and the next Tuesday both will be physics discussion, and so I just prepared a few slides to walk through some basic ideas, and I like to call this part solving physics because our focus here is to help you solve the problems. Okay, there are two parts, right? One is understanding the theory, understanding the physics really well, but that requires a lot more time, and we cannot cover that in such a short course, but of course that is also a very important aspect. But what I would like to focus is how you can apply those concepts in actually solving problems. And just to give you some background about why no this could be a good thing for me to talk about, because in general, if you look at my experience so far, so this is just a brief bio about what I do exactly. So I studied at M Prakash Academy a long time ago, and so I was the JE topper from Pune in 2008 in if you look at my own JEE score back then, right? Although I am a maths Olympiad student, so I have studied lots of maths Olympiad. I later also been delivering lectures for that. But somehow in JEE, my physics score was even more than mathematics. Like surprisingly, almost like maybe just one or two questions I may got wrong in my physics JEE exam. That is quite a curious thing. And if you ask me what is the reason for that, one of the aspects is actually that your foundation in mathematics matters a lot. And so I will talk more about that how strengthening your mathematics will help you to do well at physics problems also. Okay. So basically, before we start to actually solve the questions, and we are going to cover the questions from two past papers, I think it's a good idea to talk about the overall approach, that when you are trying to solve a question, what are the steps that should go through your mind? That these are the important steps, regardless of what is the topic you are doing. And in fact, some of these ideas are common for all topics, not all subjects, not just physics. So typically, if you have a word problem, right? So some information is given in terms of sentences or maybe some diagram. So first step is to convert that into mathematical equations. So for that, we need to understand what are the most important variables which are given in the question, what are the variables which we need to find out that what is the answer being asked, and what are the intermediate variables that, often the difficult problems are such that directly from the starting information, you cannot reach the end goal. There are some like milestones in between which you need to reach one by one, and from that you can go to the required solution. So identifying those intermediate variables is the very important part, which will set you apart from other students. And what are the important formulae which connect all these variables together? Because as such, if you think about it, all the syllabus is based on your up to 10 standard curriculum only, but connecting it together is the challenge. Okay, so first step is very important, converting the problem into equations. Once you have converted it into mathematics, then the second step is just solving those equations, right? So there it is purely a mathematical operation where you need to solve maybe simultaneous equations, some vectors, maybe some quadratic equations. And so once you've done step two, you will get some final answer. But then the step three is also very important, which is that final answer will be a mathematical solution, that some variable x is equal to 5 or whatever. Then you have to convert it back into the physics interpretation, that what was being originally asked in the question. And sometimes we need to be careful because maybe some quantity you may get multiple solutions, like some quantity is positive, negative. So you need to pick the right interpretation. Like for example, if you are solving for the mass of an object, then we know the answer cannot be negative, right? So out of multiple routes, we have to pick the right route or things like that. So all these three steps are typically what we follow to solve any question. Okay. But in addition to this, when you are solving a physics problem, some additional points you should keep in mind to solve that problem. So one thing is that always useful to draw a diagram of what are the objects given, like how are they positioned with respect to each other. That if there is an object, is it falling towards the ground, away from the ground, or what are the forces acting on each object. So there is a concept which you will study in 11th standard called free body diagram. The idea is that you draw with arrows all the forces acting on each object, because once you know the sum total of all the forces, then you can apply Newton's law, like F equal to ma, and do all the calculations. Okay, so drawing a diagram is very important. Another important thing is making sure you choose a right sign, like positive sign, negative sign to each quantity. I mean, should not get confused into labeling the signs in the right wrong way. Like maybe an object is moving to the right, but the force acting on that is to the left. And many such like confusing things can you can get misled if you don't have a standard convention. So we'll see examples that how you should be very systematic and avoid these kind of mistakes. And also make sure that you follow standard system of units like MKS or CGS system. The question may try to trick you by presenting information in different units, but you should make sure to convert everything into one system and only then start to solve the question. So these are some basic ideas which you need to keep in mind while solving the questions. Okay, so this is how you should approach any new problem. But another important thing we should talk is what is the background preparation, that before going to the exam, how you should plan your homework, how you should plan your study, so that you have the right tools available at your disposal when you actually attempt the exam paper. So for that, what are the most important things you should keep in mind? So first thing is that, as somebody already mentioned correctly, that understanding the basic concepts is very fundamental. So you should know all the basic laws of various forces like gravitational force, electric force, conservation laws like momentum, energy, and even other formulae related to buoyancy and things like that. So developing the understanding is the first step. And again, this course is very short to deep dive into this topic, but you should prepare this on your own. Along with that, the theory should also be converted into problem solving techniques. And so what does that mean? That all the formulae that you know, right, they should be nicely organized so that you know every topic and every subtopic you have nicely categorized all the important formulae, kept them in a short revision document. You know, if you have studied for one full year, you may have filled a 200-page notebook, but you cannot scan a 200-page notebook on the day before the exam. So you have to create your short revision material of just a few pages which captures all the important formulae, and it should be as per your understanding. So it should you should not copy somebody else's notes, because they may present the data in a different way, you may would like to present it in a different way. Like just to share an example, that even I have prepared my own revision notes. So if I show you how I like to write the equations, I have created this kind of a table format, you know, where like column by column I have given one formula or one set of related formula. What are the variables? There is a some concept called degrees of freedom, which I will explain soon. And like that, topic by topic, I have prepared my own what we call revision material. Okay. So you can do it this way, but it is not necessary that this is the only right way. There is no right or wrong. Whatever is helpful for you. Somebody may like to draw diagrams, somebody may like a table like this, somebody may like to draw a graph, whatever it is. Like pick your own comfortable medium to represent that information. But it is very important to develop this revision habit, because it is going to help you for all the JEE preparation for the next 2 years. Okay, so this is a tip for you for your entire JEE preparation, that have a really good revision material, and it should not contain just the basic formulae but some advanced formulae also. So what do I mean by advanced formulae? It is like starting from the basic formulae, you can create special cases of the ideas which you are going to see again and again. Like just to look at the first example, like if you have an object which you drop from some height and it is going to hit the ground, so how much time does it take? So if you think about it, you know the kinematics equations of motion. So based on acceleration, you can calculate this every time. But repeating this calculation for every question, you are going to waste a lot of precious seconds. So what if you had this formula ready for you available and you quickly apply it? Because and you take advantage of this format where the final answer is all that matters. We are not asking you to write all these steps. So like that, every typical scenario like calculating the kinetic energy, potential energy of various objects under various typical conditions. Or if your object is submerged in some liquid, it is floating, then how much volume is displaced, and those kind of formulae, and so on and so forth. So in every topic, you should prepare these kind of special formulae, which will save you a lot of time. Because as again somebody mentioned, that time management is very important. Okay. So all of this material has to be very well documented as part of your preparation strategy. Okay. And then another important point, which as I started by saying that mathematics is a very important foundation to apply physics. In fact, just today, earlier, I was watching one YouTube video. I'll share the link with you later, that a lot of expert physics debate about this, that why is mathematics so important for physics. So it is a very fascinating topic. For us, what is important is we should be very efficient in solving mathematics, that whatever equations you are getting, linear equation, quadratic equation, or simultaneous equation. So you should know various ways to solve these. Like for quadratic equation, do you know two or three different strategies? That one is completing the square, one is just factorization by observing the factors. So one is applying that b square minus 4ac formula, and so on and so forth. So knowing all those approaches and picking the right approach to solve the equations quickly and accurately, this is something that you should be an expert in. Okay, and that should not become the bottleneck, that you know all the physics but you made calculation mistake, or you did not know how to solve an equation. That should not be the reason why you did not score well in physics. Okay. So these are the top points I think that you should keep in mind. There may be few other points also like this that based on your experience you would like to add, but these are the basics of preparing well for physics. Okay. Um, so we are going to start solving the questions soon, but before that, just want to quickly talk about this topic called degrees of freedom. And this is a somewhat advanced topic in the sense that typically you study this topic properly at higher mathematics. Maybe after 12th standard, you will study this topic. But I feel that this is a important topic where at least knowing the basic idea will be very useful for all of us. Okay, so that is why let me just explain what this means. So degree of freedom is a term used when you have multiple variables or multiple parameters in your system. So, and the question is that out of those parameters, how many parameters you can choose so that after that all the other parameters don't change. Okay. So just to give an example, okay, let me. So can you see the screen? I'm writing something over here. Okay. So I'm picking the example of simple interest. Okay. So everybody knows this formula, that simple interest is P principal into number of years into rate of interest upon 100, right? And we also know how much is the amount. So amount is principal plus interest. So in all of this, you will see that there are how many variables involved? Five, right? So P, N, R, A, I. So out of these five variables, are we free to choose the values of all the five variables anyhow we want? No, right? Then that the system will not be consistent. So for consistency, I can choose any three variables. Like suppose I'm given principal is 1000, number of years is some 3 years, and rate of interest. Okay. Then if I know all of this, can I find the rest of the values? Right? So I can apply this formula and get the rest of the values. So we say that this system has 3 degrees of freedom. Okay. Sometimes it is just written as DOF to say degrees of freedom. Okay. And the important thing is it could be any three variables. See, right now I gave example of P and R, but you could choose some other way. Somebody may say I have given amount N and R. Even then you can, with some calculation, you can see that I can find the remaining ones. Okay. So out of these five variables, any three are sufficient. So therefore we call this a system with 3 degrees of freedom. So like that, every set of variables has this kind of property, that degrees of freedom. And this is applicable throughout all domains, not just for physics, in mathematics. Like for example, you in school, you must have done questions of profit and loss, where your cost price, sales price. There also you can think in this term, that how many variables are required. Out of that, rest of it I can determine. Like in Newton's laws of motion, like F is equal to ma. This has 2 degrees, right? Because out of these three variables, F, force, mass, and acceleration. If I know any two, I can find the third one. So like that, every set of variables has some degree associated with it. Or to say one more example, so we know kinematics equation, that V is equal to U plus AT. So this has four variables, but the degree of freedom is three. Or even if you add displacement to that, even there the degree of freedom remains three. So like that, one homework I'll give you. So first homework for you is try to find as many examples of various equations or variables and try to find the degrees of freedom for each of them. Okay, so try to make this list of as many examples as you can find to establish this idea in your mind that what is the concept of degrees of freedom, and then you will see that how this is useful because see you may be given some three variables, that variable x y z is given, and you want to reach some other variable p q r. So maybe directly you may not be able to reach from here to here. As I said that there may be some intermediate variables that you know how if you go from one destination to another, like if you want to go from Pune to Mumbai, you cannot directly jump, right? There are cities in or towns in between that from Pune you have to travel to Lonavala, then somewhere else, and like that. So all these intermediate uh, halting points that if you want to determine, then this degrees of freedom is a very nice way to think about that. Okay. So try to leverage this idea of degrees of freedom as much as possible in various examples. Okay. Okay. So that was one short topic I would like to share with you. So with that, I think let us get started with the actual solving the questions. So I'm going to study or discuss two question papers, so January 2023 and April. And out of that, only the physics topic I will be discussing. So there are 10 questions of each year, each paper rather. So total 20 questions we have to cover today and in the next Tuesday. So we will roughly cover 10 questions in each session. And last time in the previous batch, I had split this topic wise. So I used to focus on one topic in one session, but this time I'm going to change it a little bit. So this time, let me solve one full question paper today. So we'll complete January 2023 all questions today, and the April paper we'll do next time. Okay, and do you know why I'm doing this? Just because otherwise I will get bored. Okay, that is the only reason. And this is something important. I want to say that because I have been teaching for a long time now, but I try to not repeat myself because if there is something new, something creative that you're doing, that will keep your mind fresh, that will keep you interested. So I would like to do something different this time. Why should I repeat the same lecture which I gave 1 month ago? So in the same way, you should also think about studying that way. When does study become boring? When you keep doing the same thing again and again. But it is in your hand to mix it up a little bit, try something different every time. If you do that, then you will keep on enjoying studies. Okay, so that is the only reason why I'm going to change the order. Otherwise, it is just the same questions, nothing different. Okay, so let us start with the very first question. So, on January 2023, let me share the paper. Okay, can you see the paper? So we'll start with the very first question. Um, Well, for the first few questions, let me solve it without asking you to share your solution, just because I want to establish some common ground that what are the standard practices or standard thoughts which you should think about when you start looking at a question. And then after that, maybe the next half of the session, I will ask you to attempt the questions on your own. Those who have already attempted it before or who are seeing it for the first time, I would like to hear from you. Okay, but so let us start with the very first question. So I'll just give 1 minute for us to read the question. Okay. So let us start to apply the ideas that what we said earlier. So very first thing we should try to do is let us try to draw a diagram to convert the information in some kind of visual picture. So we understand what are the objects we are dealing with. So what is given is that And this kind of approach is very useful, that we should draw time snapshot, like how you take a series of photographs. So we should take a photograph of what is the initial condition, after a while what happens, and after that what happens. So this kind of a time series is very useful. So the first information given is that the object, the balloon, is at some height from the ground. So it is given that it is 132 meters from the ground, right? And also it is given that the balloon is rising at the speed of 8 meter per second, right? So this is at the, if I say time t is equal to 0, this is the situation. Okay. And at this moment, what is given is that a small steel object is dropped from the balloon and it fall to the ground. So here you see the mass of that object is given as 10 grams. Uh, but if you read the question properly, you will realize that the mass is not really important, because the object is going to fall down under gravity, right? And we know that how much is the gravitational acceleration. So, I mean, if you say the mass is m, and then the gravitational force on that object is m into g. So then if you equate this with the f equal to ma and find the acceleration, it is going to be g only, right? So why bother with dealing with the mass at all? We only care that it is going to fall under gravity, right? So that information is kind of unrequired, not required. Okay, so let us say at this point the mass is dropped, which is going to fall at the gravitational acceleration. Okay, and then when it hits the ground, we have to find something else. So let us draw the second picture, that what will the picture look like after some duration when that object has reached the ground. So during that time period, what will happen? The balloon will keep rising, right? Because we are not told that the balloon stops rising. So the balloon will keep rising, and at the rate of 8 meter per second. One important point is that when that object is released, right? See, because it will carry the balloon's momentum with it temporarily. So the initial velocity of this object is also 8 meter per second. So if you look at the trajectory of this object, it will not directly fall to the ground. It will actually briefly it will rise and then fall, right? So that is an important point. It is not going to directly start falling. And the reason for this is Newton's first law, that if an object already has a velocity in upwards of 8 meter per second, it is not going to change suddenly. The force will act on it and slowly it will change. Okay? So this is the picture basically. And what we have to find out is now, at the moment the object reaches the ground, how much is this distance? So if we call this distance capital D, that is what we are interested in. Okay. So this is the basic setup. So let us now start to think that what is the, how we should solve this question. So for this object, if you want to apply kinematics equation, right? Because the kinematics equation are going to relate all the important variables that we care about. So uh, the initial velocity of this object. So the first point was drawing a good diagram. Now the second point is picking the right sign. So let us use the convention always that upward pointing arrows are positive and pointing arrows are negative. Okay, so let us be consistent in this terminology all the time, so that we avoid all the confusion because of choosing wrong signs. Okay, so in that way, I should say that the initial velocity u is plus 8 meter per second, right? Then the the acceleration will be minus 10, right? Minus 10 meter per second square, right? It is the acceleration due to gravity, which is 10 meter per second square, but it is in the uh, downward direction. So I am writing it as minus 10. Okay. And then from the first picture to the new picture, right? From the time 0 to time t, the time is of course t. How much is the displacement? That how much has the object traveled? So it is 132 meters, right? But again, negative 132 because the object is falling down. So it is negative 132 meter. And so now thinking in terms of the degrees of freedom concept, that I have been given three information. So technically I can find anything else that I care about. So for example, here let us say we care about the time taken. We need to know how much time it took. So I need to just plug these values in the right formula where U, A, S and T are involved. So is there any formula we know which has all these four quantities? So it is the second equation, right? Ut plus half at t square. So in this, the t is the only unknown. Everything else is known. So I just need to solve for it. So you see at this point, we have completed the conversion of all the physics into mathematics. Now it is just purely solving the quadratic equation. Okay. So now let us solve that equation, right? Let us put in the values. So I'm going to get minus 132 is equal to 8 times t plus half times minus 10 into t square. Okay. So now this is just pure calculation. So I'll do it quickly. I hope everybody is comfortable with how to solve equations of this kind. So, okay. So if I take everything on one side, I'm going to get 5t square. Okay. So then I can directly try to solve this as. So if I plug this in the formula, right, minus b plus minus, let us do that. So I'm going to get b plus or minus root b square minus 4 is to 64. Right. By the way, in case I make any calculation mistake, please stop me and correct me. Hopefully, I will not do that. Okay. So therefore, the quantity under the root is. And by the way, because I'm explaining, I'm taking the time to write every step. When you're solving this kind of question in exam, you are supposed to skip lots of steps in between, like do them in your mind, like directly. Generally speaking, your mind is faster than your hand. Okay, so if you try to write down every step, it will actually slow you down. But if you do it in your mind, you can speed things up. Okay, so 2704, and I think that is the square of, it should be 52 square, right? Yes, right. So it is 50. So yeah. So you see that time has two roots. So it has a positive root and it also has a negative root, right? And so this is where the step three matters. That out of these two, which root you should pick. So here clearly we are going in the future. So we expect t to be positive. So that is why we pick the first root. So we don't have to bother solving the second root at all, right? So I get t is equal to 6 seconds. Okay. So basically the difference between the first picture and the second picture is 6 seconds. And in that 6 seconds, what has happened? The balloon has continued to climb. And so how much will it climb in the 6 seconds? So by 8 meter per second, it will be 6 into 8, which is 48 meters, right? So the total distance of the balloon from the ground, so the total distance D will be the 132 plus 48, right? So that is equal to 180 meters, right? So the total distance from the ground is 180 meters, and what they have asked is actually d upon 2. So because they have to answer in two digit, right? So that is why what they have asked is d upon 2, which is 90. Okay. So I mean, we took a fair amount of time to solve this question, but that was because I was explaining the concepts. In actual exam, I think you can do all of these steps in your mind and finish it quickly. But I hope that the approach is clear. The focus is on having a systematic approach, that what the solution is not that important. What is important is what is the process, how you should think of the problem systematically to get the solution. Okay, so first drawing a good diagram, then defining the variables, the known unknown quantity, choosing the right equation, the formula which relates all of that, then solving the mathematics to get the answer, then interpreting it back into the given question. So all these three steps are important. Okay, any doubts? Okay, then maybe we can move on to the next question. And I mean, again, because we are we don't have a lot of time, so I cannot pause too much after every question. But as a homework, you should also think after this lecture is done, that what you learn from every question, that what are the things that you learn and which you should try to apply in the next paper. Okay, so then going to the question 12. Again, I'll just wait for a minute. You want to read the question? Okay, so again start to think that what is the information given, how will you try to capture it in a diagram, which variables you will choose. So yeah, the mental picture should be clear in what is happening in this overall configuration. Once that is clear, then a lot of confusion will get resolved, and you will be able to confidently solve the problems. It is not just about somehow reaching the finish line, but having the confidence that I am doing the right thing, and uh, proceeding that way. So let us see. So the what is given is the block of 10 kg mass. Okay. Then there is a wind force of magnitude equal to half the weight of the block. So you see one more thing which is often used in question is that they will give you indirect information. See, they could have easily told you the magnitude of the force, but instead of giving the value, they have given it in some other terms. But it is our job to quickly convert that into simple way. So instead of saying magnitude equal to half the weight, we can directly know what is that value, right? So when we say half the weight, right? So if the mass of the object is 10 kg, then the weight is mass into gravity, right? So 10 into 10, which is 100 Newton, is the weight. And so half of the weight means 50 Newton, right? So what they are saying is there is a 50 Newton force acting towards the east, right? So like that in just while writing or while drawing the first diagram itself, we have converted that word information into numerical information, or sometimes we have to keep it in variables, but it is more concrete way of representing the same information. Then at some moment, the velocity of the block is u meters towards east and it is at point P. Okay. So let us say this is the point P and the velocity is, how much is it given? U meter. So we don't know. So it is u meter per second and plus u because it is given to the east, right? So again, east. So we are taking the convention that anything pointing to the right is positive and anything pointing to the left will say is negative. Okay. Then, so this is the initial picture. Then at that moment, another force towards west started acting on the block. Okay. So at this moment, something else happened, that there is one more force which is introduced at the same point, which is toward the west, right? And we are given the magnitude of that force. Again, we did not know the value of that force, but only it is 1.3 times the weight. So again, we know that it is 1.3 times 100, so which is 130 newtons, right? So we know all the forces acting on that object. And so what is important, do you know the net force, that the sum total of all forces, the 50 to the right and 130 to the left. So, effective force is 18 newtons to the left, right? Because the 50 will get cancelled and 50 to the left, right? So this is the total force acting on that object. And now under this, the object will have some motion. The block came to a halt at Q, which is 4 meters away from point P. So after some time, what will the picture look like? See, the block has velocity to the right, but it has a total force to the left. So it is going to decelerate, right? So it is going to keep reducing in speed until it comes to a complete stop at the point Q. And this distance is given as 4 meters, right? So this is the information given, and we have to calculate U. Okay, so again, like what are the variables given? So we know the total acceleration, right? The acceleration is 80, and or I should say it is minus 80, right? Because it is pointing to the left. Sorry. The force is minus 80 newtons. And so if I apply force equal to ma, I'll get the acceleration as mass is 10, so it is simply minus 8 meter per second. So this is the acceleration. The initial velocity is u. So I have to keep that as u. That is an unknown variable. What else do I know? I know the final velocity, right? Because I know the object comes to a stop. So final velocity is zero. And what else do I know? I know the distance. I know that it has traveled 4 meters plus 4. So it has traveled to the right. So again, I know three quantities. So I can find any fourth quantity. So can I find the u? So like again, think about what are the equations do you know? Can I directly find u from this equation? So for example, you know the formula v square is equal to u square plus 2as. So again, applying, converting everything into the mathematics. So we're going to get 0 is equal to u square plus 2 into minus 8 into plus 4, right? So u square will be 64. So u is again, u square can have two roots, positive and negative. But in here, I'm going to take the positive one because I already know the object is traveling to the right. Okay. So therefore, the answer is plus 8 meter per second, and that is what we wanted to write. Right? 8. Let me just check if the answer is correct. Well, yes. Okay. So you see how with a very systematic approach, for those of you could already solve this question before, very good. But those who could not solve it, understand that how we are able to use a very systematic approach to finish the question. And in fact, when doing this question in your exam, you should be even faster. That you can do these things quickly in your mind. Again, as I said, always the mind travels faster than the hand. Okay. So your thoughts should quickly come in this order. That this is what we need to do. Okay, so moving to the next question, question 13. So the first two questions were about like motion under acceleration of some kind. Question 13 is about buoyancy, force, the density, mass, volume, those kinds of concepts. Okay. So again, what is the information given that it is about an object floating in some liquid and it is partially floating. I mean, some part of it is above the liquid, some is submerged in the liquid. So if I have to draw the diagram very roughly, and in the paper, the what the diagram is given is two dimensional. It is a front view, but we know it is a 3D object. So if you want, just for our understanding, we can draw it as slightly, angle. So it is like something like this, right? This is the object. So this is the level at which the liquid is like the level up to which the object is submerged inside the liquid, right? And then what else is given? So one interesting thing here is that if you look at the information given, it has given the distance that the first top half is 0.3 meters, the total height is 0.6 meters, there's some capital D given, the base, the diameter of the base, and those kinds of things are given. But if you think about it, right, that finally this question is about how much of the object is floating or how much is it has it sunk below the liquid. And if only thing that matters is that the top half, that the total height of the object, whatever it is, only half of it is above. Okay. So now this is where basic mathematics will help you a lot because if you think about it, this short part which is floating above is like a small cone and the total cone is exactly twice the dimension, right? So if I call the volume of this top cone as V, so the basic idea which we all should be familiar with that if the size of the object doubles, what happens to the volume of the object? So thinking it of a cube, right? A cube of length 1 and a cube of length 2. So when the side doubles, the cube actually becomes cubed, right? So 2 raised to 3, 8 times. So in the same way, if the top part is V, right? So total volume of the whole object will be 8 times V. Okay, I hope everybody understand this concept that when the dimension becomes double, it is going to be double in all three directions, right? Height, width, and breadth. So therefore, the total volume is 8V, and therefore the remaining part, right, the part below is going to be 7V, because then V plus 7V will become 8V. Okay. So just knowing this ratio, that 1:7 ratio of the top part with the bottom part, that is all we need to know. We don't need to calculate the actual volume. Okay, because that is not going to matter. So this intuition, this understanding is very important to save your time. See, if you calculate the volume with the variables they are given, you will still get the answer, but you will just spend more time without any reason. Okay. So now let us start to apply the information that it is floating in the liquid. We know the density of the liquid. So the density of the liquid is given as 16 gram per cc, right? And then so now we have to find out the density of the metal. So what is the density of this object, right? So I mean, what at first it may seem that there is not a lot of information given that how are you going to solve this question. But again, let us apply the concept of drawing the forces. So, what are the forces acting on this object? And so there is obviously the gravitational force, right? So that the gravity will be equal to how much the mass of the object into the gravitational pull, and then there will be buoyant force, right? So if I show the buoyant force as F subscript B, so that is the buoyant force. And how much is the magnitude of the buoyant force? That you should know the formula that the buoyant force is equal to the weight of the displaced fluid, right? So how much fluid was displaced by the object, that is what the buoyant force is going to be. So in other words, this 7V volume, right? The weight of that 7V volume of liquid is going to be the buoyant force. So we can quickly write it as gravitational force into the volume of the displaced fluid. Okay. And we know that the object is stationary, it is neither rising nor falling. So what should happen, that the two forces should perfectly cancel, right? So therefore what we expect is that the mass of the volume, mass of the object into G should be equal to this buoyant force. So it is equal to G into the volume of the displaced fluid. Okay. And you see right now I'm not substituting any variables here. I'm doing that for a very particular reason. So first thing you notice is that G is going to cancel. So we are only saying the mass of the object equal to volume of the displaced fluid. Further, the mass of the object can be written as, because we know density is equal to mass into volume. Density equal to mass upon volume, right? So I can replace mass with the density of the object into the volume of, now this is the volume of the total object, right? Because that doesn't matter how much it is sunk or how much is it below the liquid, above the object does not matter, right? So total volume of the object into its density is equal to uh, volume of displaced fluid, right? And again, uh, so if you think about it, right? Wait, I think I made one mistake here. Oh, I made a mistake here. Sorry. Uh, in this, I should say mass of displacement, not volume. Everywhere it is mass. Okay. So the important thing is this formula is true for every object which is submerged partially. There is nothing special about this question. So what I was saying earlier that you should prepare your special formulae. This is exactly what we are talking about. We should have this formula ready so that next time we are going to solve this kind of question, we should not have to repeat this calculation, right? And even we can go one step further because again, mass of the displaced fluid can again be expressed as density of displaced fluid or density of fluid into volume of displaced. Okay. And this part can be copied as it is. Don't have to write it again. Okay. So again, keep this in mind that this kind of formula will be very useful to save your time. That next time you solve a question like this, you should directly apply this formula. Because now if you now go back to the other question, that suppose you had this formula ready with you, right? Instead of deriving it. And now if you look at the question, you'll see that we have all the information required. Because like the density of the object is the unknown variable, right? So let us call that D, right? That is the unknown. Do we know the volume of the total object? Like going back to diagram, the total volume is 8V, right? So total volume is 8V. And on the right hand side, density of the fluid is given as 16 gram per cc. And volume of the displaced fluid, that how much volume was below the level of the liquid, that is 7V. So you see, if you know, if you have this formula ready, this question should be finished in 30 seconds. So, and you again conveniently do see that the capital V is going to cancel. And so we directly get D is equal to, which is 14, right? So the answer is 14. I think that is what they're asking for. Find the density of the metal. Okay. So again, pay attention to this, that having this formula ready will save you a lot of time. So make your revision material full of this kind of special cases. Okay. And again, so that is an important lesson to learn. Another important lesson to learn is not all the information given in the question is necessarily required. Some of there is just given to distract you. Just as one of the previous question, the mass of the object was given just to distract you. In the same way, here also. Okay. Okay. Then next question, question 14. Okay. So to solve a question like this, I mean, actually the only thing you need to know is the electric force between two charges. So if you know that formula, see, that is what is kind of so brilliant about this kind of question. They are not relying on you to, learn or mug up tons and tons of books. That we are not asking you to know thousands of facts. Like we are not asking what is Newton's birth date, or we are not asking you that in which year he discovered gravity. What is important is, do you know the force of gravity, how it works? Do you know what is electric charge, how it works? So the focus is on, can you apply the knowledge, not that you can learn, like memorize lots of facts. That does not mean, by the way, that memory is not important. We are not saying that you don't need to memorize anything. In fact, memory is very important. As I said, that if you memorize the formula, memorize the techniques, it will save you a lot of time. But the focus is on applying the all that knowledge. So what is the diagram saying that some two, four, two. So the initial diagram is that there are two electrically neutral particles X and Y which are placed some distance apart. Okay. So we are given two particles X and Y, and the distance between them is given as 1.5 Q meters. Okay, where this Q is just some unknown number. We don't know the value of Q, but they are just given it for convenience because that Q is going to cancel. So that is why they are given that 0.5. And initially they are neutral, right? So the total charge, if I write the charge, is 0 and 0 in both cases. This is the initial picture. Then after some time, n electrons move from X to Y. Okay. And what they are given is the charge on the single electron is minus q coulomb, right? So now think about it, that if one electron has a charge of minus q, right? And the, let us say one electron travels from X and it goes to Y. So after this change happens, can somebody tell me that how much will be the new charge in X and new charge in Y?
Sir, in X it will be plus Q and in
Yes.
Y it will be minus Q.
Yes, correct. Because why? When the electron arrives at Y, one negative charge has arrived, right? So therefore the total Y which was neutral will become negative. And initially X was 0, and when one negative charge has left, so the remaining, let us say it is a proton and neutron pair, out of which the, sorry, proton and electron pair, out of which electron has left. So the proton is left, proton is remaining now. So therefore it will be plus Q in the left hand side. And basic principle that sum total of the charge has to remain constant, right? Conservation of charge. So if initially the sum is 0, afterwards also the sum has to be 0. So this was with a single electron, but now we are giving that n electrons are moving the same way. So after total n electrons moving this way, it will be just plus nq and minus nq, right? So now first point is plus nq and second point is minus nq. Okay. So I hope everybody understands this principle. So therefore, if these are the charges, then what is the force acting between them? So first is that these are opposite sign forces, so they will attract, right? We know that opposite forces will attract. So therefore, the force will be attractive on both sides. And then how much is that force? So do we know the equation, the Coulomb's law? So for that, we need to know the that Coulomb's constant, which is given this 18 into 10 raised to minus 2. So that Coulomb's constant into the product of the two charges, right? So the first charge into the second charge upon the square of the distance between them. So 1.5 q, which is the distance between them squared. So this is the force acting, and we are given that value of that force is 288 Newton. Okay. So now in this whole equation, if you see, uh, n and q are the only unknown variables, and in that, if you observe the right hand side carefully, q is going to cancel, right? Because we have q square in the denominator and q square in the numerator. So actually, the only unknown variable is n here. So all you have to do is solve for n, and if you just take everything to one side, so if I keep n over here, and by the way, what is happening with the sign? Why is the sign not matching? I think there is some maybe the positive, negative, that is why the sign is not matching. I should maybe, because this is an attractive force, maybe the sign should be negative. For now, let us ignore the sign, okay? Because we know that we can keep everything positive. So for now, let us only deal with the magnitude, okay? So instead of writing minus nq, I'll just deal with the magnitude, the absolute value. So therefore, if I just rearrange everything, I'm going to get n square is equal to 288 into 1.5 square upon 18 into 10 raised to minus 2, right? So I just need to calculate this. And I'm not writing q because we already understand that q is going to cancel out. And so if I take the square root of everything, I just have n is equal to square root of this whole thing. So again, just to skip some step, that in your mind you can do this quickly, right? 1.5 square root will be 1.5, 10 raised to minus 2 will become 10 raised to minus 1. And this 188, this 288 upon 18, one factor of 2 can get cancelled. And so actually I can just write 12 upon 3, right? And so if I just calculate this further, it is going to be 4 into 1.5. So it is going to be 6 upon 10 raised to minus 1, which is the same as 60, right? So therefore the answer is 60. So there are total 60 particles, 60 electrons which went from the first charge to the second charge. Let me just check the answer. Question 14. Oh, 61. So you see, I made a mistake. I was in a hurry to write the answer. I did not read the question correctly. So make sure you don't make the mistake. See, what they are asking is not the value of n, because they also want to test whether you know whether the force is attractive or repulsive, right? So here we know the force is attractive. The two objects are going to attract. So we have to write n plus 1. So we have to write 60 plus 1. So the answer you have to write is 61. Okay, so that is the answer, 61. If the force was repulsive, they would ask to write 60 minus 1, 59. Okay. So again, you see, it is testing very basic ideas. You do know the Coulomb's law. Do you know the fact that total charge remains conserved? So if any electrons have gone from one place to another, it will be plus nq and minus nq. That is all that is
Sir,
being
excuse
discussed.
me.
Yes.
Sir, I didn't get the concept of plus NQ and minus NQ.
Okay. Did you understand what happens when one electron goes from first particle to second one? So here, what is happening? The first x will lose that electron, so it is going to get a positive charge. So therefore, it is plus q. And while gain the electrons, it is going to get minus q, right? So this is for one electron. If one more electron does the same thing, it will be plus 2q and minus 2q. If three electron do it, is plus 3q and minus nq. So when n electrons do it, it will be plus nq and minus nq, right?
Yes, sir.
Okay. Okay. Any other doubts? Okay. Just one side note that this Coulomb's law, right? Attraction between two charge, attraction or repulsion. If you look at the formula, it has a very similarity to gravitational force, and that similarity is not just by accident. It leads to lots of interesting connection between the theory of electricity and theory of gravity. So if anybody is interested to discover more information, you will find that lots of laws, lots of formulae between charge and gravity are overlapping because of this very basic fact that the force is inversely proportional to the distance square. Okay. Okay, so that was question 14. Then question 15. Sorry, Jagtap, Alokika, what formula you want me to repeat?
Sir, I did not understand which law had been used for the formula you put over there.
Okay, let me just write the law very particularly. So in general, if you have some charge Q1 and Q2, and you know the distance between them, then the electric force acting, and by the way, because of Newton's third law, right, it will be equal and opposite. So whatever force is acting on the first object, equal and opposite force will be acting on the second object. But the magnitude of that force, so there are two things here. What is the magnitude and what is the direction? So direction, we understand that opposite forces will attract and equal or similar forces will repel. But the magnitude is given by Coulomb's constant, which sometimes denoted by C, into the product of the values of those charges upon the distance square. Okay. So this is the formula. And I mean, if you compare this with the gravity uh, situation, there is a gravitational constant into the first mass into second mass upon the distance square. So you see it is almost very similar looking formula. Only thing changing is the constant is changing, and instead of charge we are talking about mass, but the distance square, that part is common. And of course, one important difference is gravity will always attract. We don't have negative masses, so gravity cannot repel. But in electric force, it can sometimes repel. Okay, any other doubts? Okay, question 15. So actually from this question onwards, I would like to invite you to share your solution. Those who have already solved these questions before, I would like to hear your thoughts that how you are approaching the question. So anybody who has already solved question 15, you can raise your hand. Okay. And those who are not raising your hand, then I would like to know either you tried this question and could not get it, or maybe somebody has not attempted this question before. So who has not attempted this at all and who has tried it but got stuck somewhere? Yes, Manisha. Yeah, have you already solved this question?
Sir, no, I have not attempted it.
Okay. Okay, then let us try to solve this together. So this in general, right, when you are solving some kind of circuit, so we all know that circuit has not velocity, sorry, what we have voltage, right? Voltage and current and resistance. So these are the basic ideas, at least at the current level. These are the most important ideas. And when you have resistors, right, the most important concept is what is called equivalent resistance. I hope that you have studied this concept in your school syllabus, that when you have resistors in series, resistors in parallel, then you have some formula, right? That how you can combine them. So this question is just testing that idea of equivalent resistance. That can we convert this whole diagram into a single resistor? And if we can do that, then it is simply applying the V equal to IR formula. Yes, Manisha.
Sir, where is the current flowing from?
In this diagram,
Yes, sir.
see in general, so let me just draw the diagram in my in the very general sense, if you have multiple batteries and it is a very complicated diagram, then it can be a real challenge to figure out that where the current is going. But here, because the information is somewhat simple and most important, we have only one battery, right? Only one voltage source. So therefore, it is somewhat simple to decode that. But anyway, let me do it properly. And one more thing is given is this, right? And what is the magnitude given? 312 volts, 60, 35. Okay. So, as per the symbols, we know that this is the positive terminal, this is the negative terminal, and always the current goes from the positive to the negative. So, the current will leave from this wire and come back to this wire. But at this junction, what will happen? The current will split along multiple directions, right? So, if total current of, let us say that 10 ampere is flowing this way, it will be split into maybe 3 plus 3 plus 4 or something like that. So, we don't know the exact values right now. But even before looking at the current, our first step is to get rid of so many resistances. See, the diagram is so complicated. That is why we don't know where to start. So let us start approaching it one step at a time. So let us try to spot that can I get rid of some of these connections? Can I simplify the diagram? Because then it will be easier for me to solve the problem. So can anybody suggest? Can I simplify any part of this diagram?
Sir, 1 upon 20 plus 1 upon 10 to remove the resistance of the, not to remove the, convert it into 1.
Okay, I think maybe you're doing 2, 3 steps at a time. Let us do it one step. So very basic step. Can anybody suggest very basic thing we can do to simply?
Sir,
Let us take. Yes.
so we can cut the 10 ohm resistance because
Yes.
it it is between the same potential difference.
Yes, correct. So if you see here, this is what is called a short circuit, right? That the if you connect the starting and the end position of the wire, then the current will all of it will flow here. There will be no current passing through that resistance. So we can completely remove that resistance from our diagram. Okay. Or another way to say the same thing is that you can think of this as a small sub part. If I just draw that part separately, right? Then you have a 10 ohm resistance here, and a wire can be thought of as a 0 ohm resistance, right? So when you have 10 ohm and 0 ohm in parallel, right? And if you apply the formula, the equivalent resistance of this is 0. So in other words, this is equivalent to a simple short circuit. Okay. So anyhow you interpret it, the point is that this 10 ohm resistance can be completely dropped from my diagram. So I can draw a new diagram now. And now here I'm going to draw a new diagram every time. In the exam, we want to save your time. So you should not draw a new diagram every time. But here just for illustration, let me draw the diagram again. Hello? Okay, so if I drop this resistance, the new diagram will look something like, let me just copy paste the diagram and change one thing just to save my time. So here, copy it and okay, so in this diagram, I'm going to delete this connection. So, okay, very good. This is a good start that we got rid of one resistance. Anybody can suggest the next step now?
Sir, we can use the formula for parallel series.
Yeah, so the resistances are in parallel 10 10
Yes,
ohm.
correct. So that's 10 and 10. And now here, the diagram may not look like in the textbook, have very one particular diagram that, you have two resistors nicely shown next to each other. And that is what we call resistors in parallel. But understand that you are free to, move the object around as long as you don't change the connection. So as long as the same wires are connected, you can just redraw the diagram. Like instead of drawing the 10 ohm like this, if somebody draws it like this, it doesn't really matter. It is the same diagram, right? So, I mean, if I just delete this and draw it like this, I'm not changing the connection. So, recognizing that these are two resistors in parallel, and so then applying the formula for parallel resistance, do you know that when the values are equal, what will happen? The equivalent resistance will be just half, right? So, I can replace these two 10 ohm parallel with just a single resistance of 5 ohms, right? So, let us do that again, and again, I'll draw a new diagram with this change. Okay, so now I'm going to get rid of the these two connections. So I just have one 5 ohm resistance. Okay, then the next step after this, since this 35 plus 5 can be converted to series, right? 35 plus 5. So I can replace these both of them together with a single 40 ohm connection. So let me now do that here itself. Okay. And then last step, can I combine the 60 and 40? Again, it is a series in parallel. Just because the battery looks like it is in the middle, doesn't matter, right? The connection is from point A to point B. So I could redraw the diagram in like this. If I draw the diagram like this, I am still connecting the same wires, right? Just because the wire is to the left or to the right, it does not change the values of any resistance, right? So this and these diagrams are equivalent. Nothing has changed. So therefore, these 60 and 40 ohm are in parallel. And so I can replace them with, so what is the formula? That 1 upon the total resistance will be equal to 1 upon 60 plus 1 upon 40. So I can get the value of R as, so R is 24 ohms, right? And so, by the way, this is one principle which you may have already observed, that whenever you have parallel resistors, right, the total resistance comes down. If you have series resistor, the resistance goes up. So here 60 and 40 together have given us 24 ohms. And so the final diagram has only one resistor of 24 ohms. And now this is just, we can directly apply the formula V is equal to IR to get the current, right? I think they asked for the current. Yes. So the current I will be, let's say, how much it is? 6, right? Oh, no, sorry. How much is this? Sorry, 13 amperes. Okay. So see, after we reduce the question to single resistor, anybody can solve it. But doing this step by step, that getting rid of one resistor at a time till we get this simple diagram. And what did we apply? Just simple series resistance and parallel resistance formulae again and again. Okay. So I mean, your homework should be to become efficient at doing this quickly in your mind. That now next time you look at this diagram. So after this session is over, try to look at this diagram and do all of this in your mind. That in your mind, just you can quickly say that, okay, I can ignore this 10 ohm resistance and just treat a single wire. Then this 10 plus 10 can be converted into parallel resistance as a single 5 ohm connection. Then finally this 35 plus that 5 become 40. And so basically this whole right hand side of the diagram is a single 40 ohm resistance. And so that 40 and 60 are in parallel, and maybe that one last step you will do on paper and finish the question. Okay, so that is how you can be really efficient at solving this question. Yes, Manisha.
Sir, how did the 10 get cancelled out?
At the very beginning,
Yes, sir.
see, in general, what current tries to do is take the path of least resistance. Okay, have you heard this term, the path of least resistance? That if you are presented with two options, one is easy, one is hard, your natural tendency is to take the easy path, right? So if you have one resistance like this and there is a short circuit like this, always the current will try to flow entirely in this direction. That there will be zero current in along the resistance. So no current will flow here. All the current will go like this. So it is as good as you can think that the resistor is not there at all. Okay, that is why we can completely remove it from our diagram. Or if you want, you can formally derive this also by writing the equations, but you will get the same result. So whenever you have a short circuit like this, all the current will go along that short circuit. Nothing will pass through the resistance. Yes, Shreyas?
Yes, sir. I had a doubt regarding the exam. Are
Okay.
we going to get the rough sheets for rough work?
I don't know actually. You had to contact the organizers to get that doubt resolved. I don't know. Does anybody else know this from those
Yes,
who
sir.
gave the exam last time?
Yes,
Yes,
sir,
sir.
we get
They
it.
gave the rough sheets.
They gave options. Okay.
Okay, sir. Thank you.
Yeah. Okay. Okay, so moving on to the next question. Again, I would like to hear from you. Anybody who has solved a question, what is the approach you took? So if you ask me, right, this question is actually less physics and more geometry. The physics principle is simply that objects get reflected in the mirror and the distance does not change. If you come closer to the mirror, the image also comes closer. That is all that is there. Rest is actually just geometry, if you ask me. So again, the key is drawing a good diagram and marking all the information, that what is the information given. So if I just copy the diagram in my on my paper. So I think that angle between the two mirrors is given as 30 degrees. And the object given, right, that object P is exactly between. So, you know, in geometry, what we call the angle bisector of these two, right? So the point P is on this angle bisector. Okay. And then, so we are talking about the image of this point P. So if I write the angles here, so this is 15 degrees, this is 15 degrees. And so if I look at the image of P, which means the reflection in the first mirror, right? So the object is somewhere over here. So by the basic geometry, can you see that how much this angle BOQ will be? It will also be 15 degrees, correct? Because basically we have congruent triangles here, right? So this angle is also 15 degrees. And not only that, we are also talking about the reflection of one mirror in another mirror, right? Because the mirror will reflect everything, including a second mirror. So this mirror OB will also reflect the first mirror OA. And the way it will reflect, it will be something like this, right? So what will this, if you think about it, this entire angle between the two mirrors is 30. So this angle will also be 30. And so as a result, this angle is also 15 degrees. So it's just multiples of 15 degrees everywhere. Okay, so this is that. Sometimes it is called a virtual mirror because that is not a real mirror, right? It is a reflection of another mirror. But the thing is, a virtual mirror also acts like a mirror. So this OC will act like a mirror and again reflect Q. So Q will get reflected one more time into a new position R. And again, the angle will be the same, right? The angle form, again, if you see here the geometry of the, you are going to get an isosceles triangle of some kind. And so here one more time, you're going to get 15 degrees. So all these 15, 15 multiples are there. Okay. So this is what the picture is going to look like. Okay. So, I mean, if I have to write properly, you do see that triangle OPQ and triangle OQR are both isosceles, right? And isosceles meaning that these distance OP, OQ, OR, they are all equal. Okay. And what about angle POR? Can you tell me how much is angle POR? Isn't it just 15 into 4? So it is 60 degrees, right? So therefore, what can you say about this triangle POR? What can you say about the triangle POR?
Sir, is it equilateral?
It is equilateral, right? Because it is isosceles, two sides are equal, and the angle in between is 60 degrees. So, and in the diagram also, it is looking quite roughly like it is looking like an equilateral triangle. So therefore, if this triangle is equilateral, and see, important thing is that in this whole analysis, the only thing we kind of used is the fact that P is on this angle bisector. So P can be any point on this angle bisector, does not matter, right? Any point I choose on this angle bisector, and it will get reflected in Q, Q will get reflected in R, and that triangle get formed will be equilateral. So this triangle is always equilateral, not just on this particular position of the point P, but even as the point P moves on this bisector, it will always remain equilateral. And why is that fact important? Because now what is given, come to the important part, that P is moving towards O at a uniform speed of 20 meter per second. Okay. So what is given is that this point P is traveling towards O. So it is traveling around this line only at 20 meter per second. So as the object is moving, how will the diagram change? So if you think about it, the triangle will remain equilateral, but its size will keep on reducing, right? So after some time, maybe the position of the P has changed to a new position like this. So the triangle is reduced in size. Hello? Oh. Okay. So the triangle is reduced in size now, right? But it is going to remain equilateral.
Sir, why the triangle will be always equilateral?
Because in this diagram, see, did I choose P as any special point? It only wanted, as long as I choose some point on this line, this angle bisector, it will become equilateral, right? See, the same analysis if I repeat, instead of let us say I call this point P1, and let me temporarily zoom in the diagram, and with a different color, with a green color, let me repeat this analysis. Let us say somebody chooses point P2 over here and repeats the whole calculation. So P2 point will get reflected in Q2 over here. Q2 will get reflected in R2 over here. So now this new diagram triangle P2OR2, isn't that also equilateral? So you could choose any point on this line. It will, the position of the P will change, Q will change, R will change, but no matter where it is, the triangle getting formed is always equilateral, right?
Yes, sir.
Okay. Like, in fact, let me just quickly show this in a different way. So there is a very nice software called GeoGebra. I don't know if anybody has used it anytime. It is a very powerful software. So that is why you have to use it very carefully. You know, a powerful software can have disadvantages also, that you can become so used to this software that you don't know how to draw a diagram on paper. So make sure you don't become that way. Use the tool judiciously. Use it to enhance your imagination. Don't use it to replace your imagination. Okay, so let me just draw it like that. Let us say this is my first ray. This is my second ray. Ignore the labeling. Okay, the labeling is not that important. Oh, sorry, I cannot draw the second ray anyhow, right? I have to draw it at uh, so let me rotate this square. Okay, so this is my second mirror. And if I draw the angle bisector between them, okay. So this line which I have drawn, and let me take any point P on that line. Okay, so let me call this point P. Okay, so this point P is going to move only on this line, which is what is given. Now let us take the mirror image of the point P in this line first. Okay. So this is our point Q. Okay. And now I have to take the mirror image of my first mirror, right? So I have to take the mirror image of my mirror. So this was my second mirror. And now if I use this mirror as my reflection, then Q will become R, right? So I'm going to call this point R. Okay. And our origin was O. Right? So this POR, right? This is the triangle which we are focusing on. And you see in my diagram, it is looking very nicely equilateral. And now the question is, if this point P moves on this ray, what happens? So you see this point P, now it is traveling away from O, but does not matter. But no matter where it goes, I have to stop this animation. Okay. You see, so as the point P moves, the whole triangle is reducing in size, but it is always equilateral, right? So I hope that clarifies the point. And so therefore, how can I solve this question now? That if the triangle is always equilateral, and P is approaching O at 20 meters per second, which means that the size of this equilateral triangle is going to keep reducing at 20 meters per second. And so if the size is reducing, all the sides will reduce at the same speed, right? I mean, it cannot happen that one side is reducing at 20 and other side is reducing at 30. Then the length will not match. So as P is reducing at 20, the distance between PR is also reducing at the same speed. And what was asked in the question? Find the speed in which R is moving towards P. So that is the answer is 20 because the distance between PR is reducing by 20. So the answer is the same answer, interestingly. So what was given in the question said 20 meters per second, same is the answer. So the answer was there in the question itself. Let me just check it once. Question 16. Yes, the answer is
Why
20.
is the angle QOC 15 degrees?
Why is the answer 20?
No, no. Why is the angle QOC 15 degrees?
Why is the, sorry, can you repeat which angle are you asking about?
QOC.
QOC, why is 15? Okay. Because actually what was given, right? If I just delete some of the diagram, the see OC is the virtual mirror, right? OC is the reflection of the original mirror. So if I consider that this O is the original mirror and I reflected that in OB to get OC, right? So therefore this angle which was given to be 30, therefore this angle is also going to be 30. And out of that, this was already known to be 15. So the remaining also has to be 15.
Thank you. Thank you.
Okay. So as I said that this question has very little to do with physics and mostly it is about geometry only. So again, another reason why mathematics is very important, that if you understand it well, you can solve this kind of question quickly. And now see, I had to do so much background explanation. With this, now if you look at the diagram, do you see we can finish the question in the diagram itself? In the diagram itself, can you see that this angle OAP is 15, POB is 15, BQO is 15, all of them 15, 15, 15. So angle POR is just 15 times 4, which is 60 degrees. So POR is an equilateral triangle. So therefore, if OP is reducing at the speed of 20 meter per second, RP is also reducing at 20 meter per second. So the answer is 20. So if I explain it like this, you may think that, oh, this is a very simple question. So if you build the confidence that way, you will solve the questions very fast. And that is ultimately what you need. If you are going to prepare for exam like JEE, these kind of questions should be done in your mind. If this question is taking you time to solve, like and 20 pages of calculation, then it will be very difficult for studying for an exam like JEE. So start developing the habit to do these things quickly in your mind. Okay, okay, so this was question 16. Question 17 then. Okay, so this is a question about optics, and there are some basic formulae which you need to know. When your objects which are getting, images formed through a lens, convex lens, concave lens, or even mirrors, there is some basic formula which I think everybody should know. Okay, so actually, even last time I had some confusion in my mind, but hopefully I will not make the same mistake this time. Okay. So, I think this is often called a lens equation, or maybe there is some other name used to refer to this equation. And there could be several ways of expressing this. Let me express the way which I think is easiest to understand, because it illustrates a very important principle of optics. Okay. So if I just draw it as the lens like this, okay, and for simplicity, I'm going to say that the object is on the left hand side. Okay, so this is the object and this is the image. Okay, very simple way of writing it. And so we say DO is the distance of the object. We always use the lens as the reference point. So we measure all the distances along the like perpendicular to that. And this is the distance to the image. Okay, so DO and DI are the distances. So the way I like to formulate this is that 1 upon DO plus 1 upon di is equal to 1 upon f, where f is the focal length of the lens. Okay, so you may have a slightly different interpretation, like some of the signs may be different, but that is all because like it is just convention that what to take as positive, what to take as negative. If you change that, the formula will slightly change. But in this particular picture, this formula is applicable. Okay, so where we are measuring all the distances away from the lens. Okay. Okay, so this is called the lens equation. And you know why I like this equation a lot? Because see, DO and DI in this equation, for just for my liking, I wrote this to the left and this to the right. Anybody else could come and write the equation the reverse. Somebody say 1 upon DI plus 1 upon DO is 1 upon F. It's the same formula, right? Changing the order of the terms will not change the value. But doesn't that mean that somehow what you call object and what you call image is completely arbitrary? That if the object is placed here, the image is formed here. But what the equation tells us is that if somebody keeps the object here, the image is going to get formed here. So the principle is that the light path is reversible. Okay, this is a very important concept, that it is reversible. That if a light ray travels from here to here in some way, instead of going that way, if you take a torch and shine the light ray in the opposite direction, it is going to exactly copy the path which it followed. So it is going to completely reverse the trajectory. It is not going to, it cannot happen that, from going from left to right, the path was like this, and going from right to left, the path went in some other direction. That cannot happen. If it went in this trajectory, it will also going to return from the same trajectory. So this reversibility is a very nice property that light rays follow. Okay. And so that is why I like this interpretation. Okay. A very nice property about light. Okay. But anyway, I mean, that is not important to know as such. To solve a question like this, just this formula is enough. So now if we let us try to apply this in the given question. So okay, so what is the information given? We are given that so convex lens is put between an object and a screen. So the diagram is something like this, that the lens is over here, the so object is over here, and the screen is over here. And so again, I have to say that if I call this as x and y, so the distance between the lens and the screen is y, and the object and the lens is x. So in this first diagram, if I apply the lens equation, I can say 1 upon x plus 1 upon y is equal to the focal length, which is given as 10, right? Okay, so in this is the first diagram where the image is formed. Now what is given, that now the lens is shifted towards the object by 15 centimeters, and again the sharp image is formed. So in the new configuration, I am not changing the screen or the object. So the screen and object are in the same position, only the lens is getting relocated by 15 centimeters, right? So now the lens is somewhere over here. So now what has happened? This shift is 15 centimeter. So how much is the new distance now? On the left hand side is x minus 15, and on the right hand side it is y plus 15, right? One distance has reduced, other has increased. And again the sharp image is formed. So now I can write the equation again as 1 upon x minus 15 plus 1 upon, and the focal length will of course not change. And then we have to, what do you have to find? Find the distance between object and lens. So this is the x is what we have to find out. What is the value of x? So if you see the equation on the right hand side, right, we have two unknowns and two equations. So it is just solving the simultaneous equation. So you see how we have converted everything into mathematics. So we just need to solve it now. So 1 upon x plus 1 upon y is 1 upon 10. So we need to solve this. So like we could clear the variables and rewrite these equations as, so on the left hand side x plus y times 10 is equal to xy just by cross multiplying, and on the right hand side it will be y plus 15 plus x minus 15. And see, I'm starting to increase my speed because I'm trusting that you can follow the calculations. But if you think that some step you are not understanding in the calculation, it means that you need to spend more time improving your calculation skills, that you need to know how to do basic manipulations very quickly. Okay, so these are the two equations, and we can simplify it further. So 10x plus 10y is equal to xy, and here now this plus 15 minus will be cancelled, so I'll get 10y plus 10x is equal to xy minus 15y plus 15x minus 225, right? And so now here, if you see, and I'm writing the equation side by side because the left hand side is saying 10x plus 10y is equal to xy, and here also I have 10x plus 10y equal to xy. So if I just subtract one equation from the other, like basically what we are saying is this and this will cancel away, right? Because they are given to be equal. So I can straight away cancel these two terms. So I can write 0 is equal to minus 15y plus 15x minus 225. Okay. And so again, if I rearrange this and cancel the term of 15, I am going to get, if I take here, like y is equal to x minus 15. Okay. So I'm doing multiple steps in one go now, because I hope that everybody is confident with this, that I've taken y to the left hand side and cancelled one factor of 15. So you see how can quickly reduce the equation to something easier. And so now if I know y in terms of x, which means I can substitute the value of y. So if I substitute y in this equation, right, I can write it as 10x plus 10 times y. So wherever I have to write y, I can replace it by x minus 15. Right? So both occurrences of y. So this was y was here and here. In both places I've written x now. So now this is an equation purely in terms of x, and it is looking at a equal to a quadratic equation. Okay. So therefore I just have to solve it, right? So 10x plus 10x minus 150 is equal to x square minus 15x. Taking everything to one side, I can write this as x square uh, minus 35x plus 150 is equal to 0. And so I can see the roots as minus 30 and minus 5. So x is either 30 or x is equal to 5. Right? And so now out of these two roots, which root should I pick? Whether 30 or 5. So if you wait, 30, right? Because why should I pick 30? Because after that I'm going to move the lens closer by 15 centimeters. So if my starting distance is only 5, then the lens will go to the left of the object, which will not be valid. So therefore the answer has to be the larger one. So x is 30. So 30 centimeters, is that the right answer? Question 17. Yes, 30. Okay, so again, I'll just pause for a minute. Anything you want to copy from this? And again, my focus is more on the showing you how to convert the physics into the mathematics. How to solve the mathematics properly is something that you have to practice on your own. If you think that it is a weak point of view. In fact, one thing I'll suggest you to do is, as part of your preparation, that try to categorize your uh, difficulties. That where you are stumbling, where you are not able to solve the question. Is it because of the physics? Is it because of the solving part? Is it because you don't understand the theory? Like these three, four categories. Maybe it is because you're making a silly mistake. And based on what is the problem you are facing, you have to apply a different solution. We cannot give a common instruction to all the students, right? Every student has a different problem, and so you have to address whatever is preventing you from solving the question. Okay, so okay, I think we can move on to the next question. So question 18. Okay, so what should we do for question 18? That some information is given that there is some object. So there are two objects, right? The cobalt block and the ice, right? And they are both kept in the same container. And the cobalt is at much higher temperature, like 410 degrees, and ice is at 0 degrees. And so what we expect to happen is that the heat will transfer from one object to the other, right? And most important principle is that law of conservation of energy, that because all of that is kept in an insulated container. This is the most important part, that no heat is going to escape the system or enter the system. So whatever is the heat lost by one object is precisely the heat which is absorbed by the second object. So that is all, that is the important principle here, that heat lost by first object equal to heat gained by the second object, right? So if I draw this as a diagram here, again, like the initial diagram, and I'm like to draw it like a height, like the higher temperature, I will draw it a higher position in my diagram, and the lower temperature, I press something by mistake. Okay, so the cobalt object is at 410 degrees, and I know the mass of that object also. So mass is 225 gram, and I also know the specific heat capacity, right? That is how much is it? 0.1 Kelvin. Okay. So cobalt is here and ice is here. Ice is at 0 degrees. We are given that it is at 100 grams of ice, right? And so what is going to start happening? First thing is that ice will absorb the heat from the cobalt, but it will not immediately become water, right? We know that there is a concept called latent heat. So ice will keep absorbing the heat to first become water. So if I draw the diagram, actually let me not write the information here. Just okay. So this is the initial diagram. for a while, what will happen is that cobalt will keep losing that temperature. So cobalt will keep losing temperature while the ice is become converted into water of the same temperature. So water is still at 0 degrees Celsius, 100 gram. But now this change of state is also going to consume energy, right? And so the point is that how much is the heat lost over here, right? How much heat the cobalt lost is the same heat that was gained in this conversion, right? And so we have to calculate that how much heat required to convert the ice to water. That is the first thing we have to calculate here. So how much heat will be required? It will be the mass of the ice into the latent heat, right? The specific what is the latent heat of fusion is given 80 calories per gram. So 1 gram is going to require 80 calories. So 100 gram is going to require 8000 calories of heat to convert this. And so now we can ask the question that in this process, how much temperature drop will be there? So the temperature drop of the cobalt, right? This is also the same. This 8000 is also equal to the heat lost by cobalt, right? Because again, the principle is heat lost by one object is the same as the heat gained by the other object, right? And so this is equal to the mass of that cobalt object, which is 25 degrees or 25 grams, into the change in the temperature into the specific heat capacity, right? Specific heat is given as 0.1 Kelvin. That's right. And so in this, the only unknown variable is this delta T, right? We know the exact value of the heat, we know is 8000 calories. So I'll get the delta T, the change in the temperature, as simply 8000 into 42. Right? Let me just check that. Yes. So therefore, this will be equal to till last time I solved this question. Okay, I'm sorry. Let me just do it in a different way. We can do it in this way also. There is nothing wrong with it. Like we can calculate this delta t and then do it again. But let me give you a shortcut because this fraction is looking difficult to compute, and can we avoid that calculation? Then that will be very nice. So I think the way we can avoid that calculation is that actually speaking, we don't care about this in middle state, right? In this middle state, it is still not in equilibrium because water is at 0 degrees. This cobalt is at some other temperature which we don't know. After that, the temperature is still going to continue to change, and the final picture is going to look like there is some temperature T at which everything has settled. So the cobalt has also reached the same temperature and water has also reached the same temperature. And finally, that is the picture that we are asked because we have to calculate the equilibrium temperature. So actually, I want to know that final diagram only. I don't care about this intermediate diagram as much. So let me directly calculate that final diagram. Okay. So if I want to do that, I need to know that how much heat cobalt has lost altogether. That the first step in which the water was being formed, the cobalt has lost some heat, but it will continue to lose the heat further. So I only care about this total heat lost, right? So total heat lost in this process will be equal to the total heat gained, right, by the ice plus water, right? So if I formulate it this way, right, total heat lost by cobalt should be the total heat gained by the ice plus water. Okay. So with that, in fact, let me just erase all of this. Okay. So total heat lost by cobalt will be equal to how much? Again, it will be, so if I'm calling the final temperature as capital T, it will be the mass of the cobalt into the change in the temperature. So the original temperature was 410 degrees minus the final temperature, this T degrees, into the specific heat capacity cobalt, right? This is the total heat lost by cobalt. And how much is the total heat gained by the ice/water? So that total heat gain will have two components. The first is the heat required to just change the state from ice to water, and then the additional heat required to change the temperature. So I have to add both components, right? So the first change of state will require 100 grams into 80. So that 8000 which we calculated earlier, that is the same. Plus now we have to calculate how much is the heat gained in this last step. And so that will be again the change in the mass of the substance, that is 100 gram, into the change of the temperature, which is T minus 0, which is the same as T, into the specific heat capacity of water. So specific heat capacity of water is 1 calorie per gram degree Celsius, right? So simply 1. So this is the total heat lost by the cobalt, and this is the total heat gained by the ice water, and these two have to be equal, right? So you see, this is a better approach, that we should not care about the intermediate step, which we were trying to do earlier, which would be just additional calculation, and we can skip that. Yes, Aditi?
Sir, how could you estimate that the last state will be water only? We can also say that it may be steam.
Yes, you are correct. So there are 3, 4 possible ways, right? One is that it could happen that all the cobalt became 0 degrees and still all the ice did not become water. So some ice is still left over. That is also possible. What I'm showing here is also possible, and it is also possible that what you are saying, that all the water reached 100 degrees and started to boil and become steamy. All three pictures are possible, but here you have to somehow take a leap of faith that what they are asking here. You see, if they were asking that question, right? Suppose it were the case that it is becoming steam, then we will also require the latent heat of vaporization, but that information is not given in the question, right? So therefore, we can safely make the assumption here that it is the middle state. But what you are saying is correct, that in a general question, we have to take all those things into account. And in fact, you should expect those level of question in actual JEE paper. But because we are not testing that difficult question, we will not typically have that. Okay. But what you're saying is perfectly correct, that we have to, we are not sure. We are making an assumption over here. Okay. And you know how we can check that assumption? After we do all the calculation, and if we get the value of T as some nonsense. Suppose we do everything and we get the value of T as minus 20 degrees. Then we know that definitely something is wrong. Then we have to start thinking of that possibility that, okay, maybe something else is happening. Okay. For now, let me proceed with this calculation. So now I just have to solve for capital T. So if I equate these two, that 225 into 410 minus T into 0.1 is equal to 100 into 80 plus 100 into T minus 0. Okay. So again, just quickly proceeding with the calculation part of this. So 225 into 410 minus. So taking the T to one side, I'm going to get so how much is this? 225 into, I think this is 9,000. 9225, right? So this is 9225. So that is 1225 is equal to 122.5 into T. And therefore T will be simply 10. Okay, so 10 degrees Celsius. That is the final equilibrium temperature of the whole system. And is that what they've asked for? Yes. So question 18, the answer should be 10. Yes. Okay. Okay, so again, understand the process that finally we are carrying out the equilibrium temperature at the end. So the total heat lost by cobalt in this whole process should be equal to total heat gain, which had two components, the change of state and the change of temperature. Okay, so question 19. So maybe we only have 10 minutes, so we can cover question 19 today, and question 20 we will do next time. And I would like to suggest that for next time, right, we are going to discuss the questions of the second paper, the April 2023 paper. So for that, now that we will have 1 week's time in between, why don't you attempt that paper on your own as much as possible? Like if everybody has attempted it sincerely, following the suggestions which I gave today, I feel that everybody can solve that paper. Okay, so give it a serious attempt. Let it not be the case that you have not tried the paper and then I'm just revealing the solution. See, disclosing the solution is not going to help you. Only after you have spent the energy to try the problem, after that I give you one hint, then you will actually learn and gain something. Otherwise, I know how to solve all the questions, but how will that benefit you?
Sir, we don't have April 2023 paper with us.
It is there in the on the website. Can you see
No,
on the
sir,
because
2023 is not updated.
is that the case? Because even I downloaded from there only actually. Uh, It is there, right? You see here, April 2023 question paper. It is the same. Yeah, it is there. If you're not able to find it here also, then maybe just ask somebody. But I think it is there.
Okay, sir.
Okay, so question 19 is a very interesting question because I'm trying to think of the right word to describe this question. It is a question about the, I don't know, configuration is also not the right word. Yeah, next time I'll suggest the right word. I think there is a very nice word can be used to describe a question of this type because if you notice what is given, typically if you see in all the
Radius of
questions,
momentum.
yes, it is about conservation of momentum, but I want to mention that even broadly speaking, right? See what is the kind of information given. In all the question we did before, right? The exact position was given that the father is at this position at this particular time, and the other object is at this position at this particular point of time. But here the position and the time is not given. Only it is a change of state. Okay, so maybe change of state could be one way of describing it because all it is given that previously the one object is traveling at one speed, and after some collision, something else is happening. So only thing that you know is what was the initial speed and then what is the final speed. So in some sense, the details are not important. That where the two objects collided, that is not important. What is the change in that is the only important thing. Or what important is what is not changing. Okay. So what doesn't change is the important thing. Okay. So there is a word called invariant. Okay. In mathematics, we often encounter this word invariant. So invariant means that which does not vary or that which does not change. Okay. And all conservation laws are invariance laws. That conservation of momentum says that momentum does not change. Conservation of energy says that total energy of the system does not change. Conservation of charge says that total charge does not. So all of these are like invariant quantities. So these invariants are very important principle. So here, I think particularly it is about invariance of momentum. because initially the mass of the velocity of the father is given. So let us try to draw this as a diagram. So the father is traveling at some speed given as what is it given 3 meter per second. So 3 meter per second, the father of what is the mass given 70 kg, right? And so then the daughter is also traveling at another speed in the same direction, 6 meters, right? 6 meters per second of 35 kg, right? So this is the initial picture. Then, so again, what I want to emphasize is the time is not given, the distance between them is not given. At some point, they will collide, and after the collision, together they are going to travel, and the total weight will be 30 plus 35 plus 70, so 105 kg, and some speed. That speed is also not given, right? So that speed is an unknown quantity, right? Let us say u meters per second. So the first question is, can we find the speed u? Because the total momentum will not change, right? So initial momentum will be the momentum of the father, which is 70 into 3 plus 35 into 6, right? 420 kg meter per second, right? So that has to be equal to the final momentum, right? Momentum of the system should be exactly the same. So that should be equal to the total mass into the velocity. So therefore, I can calculate the value of u as 4 meter per second, right? So therefore, the new velocity of the combined father plus daughter is 4 meter per second. So, and now what is being asked is, what is the loss of kinetic energy? Okay, so again, the total energy of the system has to be remain the same, right? So initial kinetic energy is how much? So half mv square, right? If I apply the formula, half of the first object 70 into 3 square and the second object. So this is the initial kinetic energy. And what is the final kinetic energy? Is the half into the total mass into 4 square. So this is the initial energy and the final energy. And we have to find how much energy was lost. So E1 minus E2 is what we have to find, right? That is what is given as this capital E, right? So this is the value we want to calculate. So it is just, in fact, this equation does not have any variables at all. Everything is known. Yes, Manish? Manisha?
Sir, how did the momentum of the both of the child and the father come as 4?
No, the momentum is mass into velocity, right? So mass was 105 into u. That is the momentum, and that has to be equal to the initial momentum, which is 420, right? So we are saying 420 equal to 105 into u. Therefore, u is simply 420 upon 105. So the velocity is 4 meters per second. Understood?
Yes.
Okay. So we just have to calculate, right? This is just calculation. So we are going to get half into 70 into 9 plus half into 35 into 36 minus the final momentum. So I think in all of this, I think we can take 35 common. Everywhere I see 35 common. So inside the bracket, I'll be left with 9 plus 80. So this is E. And what they have asked is actually not E, they have asked E upon 5. Okay, so E upon 5 is 7 into 3, which is 20. Okay, let me check the answer. Yes, 20. Okay, any other doubts? Okay, I hope you understood this question. Wherever somebody may have the question that actually energy is supposed to be conserved, right? Then how is the energy decreasing? Where is that energy gone? Can anybody answer that question? That how is the energy decreasing?
Here it is getting
So
converted.
the heat,
Yes, it's a heat, right? So when the object collide, because of the friction and other forces, some energy is lost as heat to the environment. Okay, but I hope the principle of this question is understood, that first step was comparing the momentum to get this value of the final speed, and then just applying the kinetic energy formula and finding the difference. So it's kind of a very straightforward question actually. But see, the important characteristic of this question was that, see, very little information was given in terms of absolute position, that how much was the separation, was it 1 meter or 1 kilometer? We don't know, like how long the two objects were traveling, but we don't care. We are caring about the total, like the I'm this is sometimes the ideas in your mind, but I cannot find the right word for it. That this is a very typical, very peculiar kind of question, very different from all the questions you've seen so far. Okay, but anyway, so we are out of time, so I'll stop here. But so I think question 20 you can attempt on your own, and we'll discuss it next time, of course, and we'll also discuss the April paper. Okay. So yeah, I think that's all. Any other doubts or any last questions anybody has? Okay. If not, then we'll stop for the day. So on a Thursday, you will have your chemistry session which Sony madam will conduct. Yes, Shreyas.